Okay, the last set of charts that we're going to see, we're going to look at are time series plots. Okay. Time series data is data observed over a period of time at regular intervals. Okay. So we have such a data in Amtrak data. Okay, so the Amtrak data has two columns. The first column is month, and then the ridership for that month in the second column. Okay. So that would be, since the ridership is observed at regular intervals over a period of time, this is a time series. Okay. So let's first read the data, Amtrak. Okay, let me. And we have Amtrak here, right? Amtrak space data. Okay. So that's going to read Amtrak data into that data frame. Okay. Now, if you look at the data frame from here, from the environment, okay, so you see there is a month. So this is 1991, January, February, March, and so on, and all the way to the end. You have up to March. Okay, so the date here is a little confusing. Okay, so this is the second two digits are the month. Okay. All right. So now if you look at the structure of the data, okay, so what you see is there are two columns, right? The first column, month, is what kind of data is that? What is the data type? Data type is character. It's not a date. It's a character, string. It's a string. Okay. And of course, this is number, that's good. Now, for us to use the time series functionality in the library called forecast, this character values must be changed to, converted into date values. So once you convert them into date type, then there are lots of things that we can do very easily. So first thing to do is to convert that first column into a date type column. Okay, and that, okay, can be done with the library forecast. Okay, so now we have forecast. We've used forecast before, right? In the accuracy computations. This library is actually a forecasting library, and accuracy is just a part of it. Okay. So now we're going to use the as.date function. Okay, so it has this as.date function that we can use to convert a date string, but the string must be a date string. You cannot convert any old string into a date. It must represent a legitimate date. But it is in string format. So we are now converting a legitimate date that is in string format into a date format. Okay. So like you can't take a string like like that, and then say, okay, as date, and convert that to date now, because that is not a date. Okay? So it has to be consistently coded as a date. You can't have some values coded as month and year, some values not day of the month and then month and so on. It must be consistent throughout. Okay? And then if you say as date, okay, and then select the variable. So this is the column that has the date. And then we have to specify, okay, what is the format in which the dates have been coded in the string. Okay. So if you go back to the data, okay, so here the dates are coded, okay. First two digits, there are two digits representing, okay, it's not the month, it's not representing the month. You have to be careful there because it is the second part which is going from 1 through 12, representing the month. The second two digits are representing the month. The first two digits are representing the day of the month. So which all the it's coding with the first day of the month. Okay. Then there is a slash in between. Okay, we must remember that as well. And then the here is coded as a 4-digit number. Okay, so we have to take all of that into account, and there must be another Y there. And for each of the different ways in which dates can be formatted, there are format codes. Okay, but we are not going to get deep into that. So for 2-digit day, numbers going from 0, 1 to 31, what we use is lowercase d. Lowercase d tells R that when you read that string, the two digits that you see at the very beginning, that represents the date of the month. Okay. And then there is a slash, so you put a slash there. Don't forget that. Then you say, okay, the next thing is a slash, so R is going to ignore that. Okay, that's a slash in the string, so that's fine. And then the lowercase m, say that percentage, the percentage sign tells R that this is the format that you have to use for converting the string into date, and then your 2-digit date of the month, and then this lowercase m is month in digits. Okay, so if you have month in 3-letter code, then there is another code for that, and if you have spelled it out completely, there is another code for that. But percentage m says month is coded as a 2-digit number, and then you have you have another slash. Okay, and then we have lowercase y is 2-digit here, uppercase y is 4-digit here. So this format tells R how to take those strings and convert them into a date type. Okay. Now, once it is converted, you have to save it. Okay. Otherwise, it will convert everything and throw them away. Right? So we need to put that back in what month? Or if you want to create another column, as a date column, and preserve the character column, you can do that too, because just in case you want to use it for something else. Okay, so I'm going to just put it back in month. Okay. Now, if we go back and run the str, you will see that the month is no longer a CHR, a character data set. So it's going to say it's a date format. Okay, month is in date format. So this is the critical conversion that we have to make. So once it is in date format, then plotting them becomes really easy. So a simple time series plot, okay, using geom_line is ggplot, okay, Amtrak, and then x equal to month, y equal to ridership, okay, and then geom_line, okay. And then, of course, you have to put a title and all that kind of stuff. Now, sometimes it is useful. So this is your time series plot. Sometimes it is useful to plot a trend line, okay, in the time series plot. Okay. If you want to plot a trend line, then you have to add that, okay. So, and that is geom_smooth, okay. And the, if you just say geom_smooth, it'll try to plot a smooth line that fits the data, okay. But you can control what kind of smooth line you want instead of leaving it up to R. Okay. So here you can specify what kind of line you want to fit, and that is given by formula equal to, then so we have now y and x, right? We have the value of y, which is ridership. We have the x, which is the month of the dates, right? So we can say y, and then if you simply say x, okay, so it's not, you're not saying anything. You're saying, okay, smooth between y and x. So it's going to give you the same thing if you did that. Okay. But you can specify what type of relationship we want between x and y, and that is, polynomial, okay, say polynomial of 1, and then wait a minute, and then we have to say what kind of method we want to use for fitting a trend line, and LM is linear model, so which is like regression analysis. So what we're saying here is fit a polynomial between y and x of order 1, which is what? Which is a straight line, y equal to intercept plus slope times x, which is a straight line, and use regression analysis to fit that line. Okay. Then it fits a straight line. Okay. Now, if you say 2 here in the polynomial, then the line that it will fit is intercept, say b sub 0 plus b sub 1 times x, okay, and then plus b sub 2 times x squared. So it will be a polynomial fit. And in the polynomial fit, the shading that you see is is a confidence interval shading. So it gives you a 95% confidence interval around the mean. And you can suppress that by saying SE, sampling error, equal to false. So if you say SE equal to false, then that will take away the shading.